Hello. Right, I will speak in English. I'll speak slowly. And just bear with me another 20 minutes. If I can reduce to 10 minutes, then we can go. All right. So I think all of us has heard about IoT and it's coming so fast and it is right now. And you have seen this slide. So in fact, I'm wearing a Garmin watch. Reason is I want to check what is my heart rate sometimes. Being fat is, make sure I don't overwork my heart. Now, I want to show a brief definition. We hear a lot IoT, IIoT, and Industry 4.0. But sometimes this term can be very confusing. Well, let me show you the next slide. So IoT is this. IoT is just something different from consumer. They focus a lot on industry, IoT. But again, Industry 4.0 is just another trend of revolution of the industry. So this is just a brief, simple understanding. If I give you another image that IoT also can be applied in smart agriculture. So this is just one example. So I was actually looking into the news, reading news. It looks like Korea are focusing a lot in autonomous car, IoT-fitted electronics, semiconductor and display, biohealth, renewable energy, which is about 50% of total Korea's R&D spending. So there's a lot of money being involved. So I guess today, as engineers, we actually would like to raise and complete design something that is fast to the market. Another image where IoT may exist. Smart home, wearables, smart city, industry, smart energy, and connected car. Now, I want to just focus on education because as an industry, you are coming from the industry, as a young engineers, when you do a hiring, we actually see a lot of challenges, especially in training new hires. I'm not too sure how many educators are here from universities, but again, if you are here, this is what we are seeing worldwide. And also as an industry, you could actually share these insights together with your colleagues and also friends who are working in the university, especially their professors. Now, when we look into IoT, like example, when Keysight does hiring, typically we look into the engineers able to incorporate sensor technology into a product, engineers incorporating wireless technology into the products. So you can see here, this is more than 50%. Whatever we do today, it must be wireless, it must be sensor related. And then about 51% engineers whose design are being influenced by IoT. And this survey is done by Electronic Design last year. Next slide shows that maybe this is not happening in Korea, but the rest of the world. We always hear that undergraduates, the moment they finish school from university, they could not find jobs in the market. But again, is it true that there's no job available in the market? Is it that companies are not hiring? But actually, that's not true. If you look into this, out of 10 jobs available, probably 30 to 40% are filled. Remaining 60 to 70% jobs are not filled. Meaning to say that there is a possibility, a mismatch between what students learn in the university that the industry didn't get attracted to. Okay, next slide, I'll just go forward. Now, if you are a professor here today or even an educator, just imagine, not only that you have too many roles, you have to write paper, you have to do research, you have to teach, you have to do like applying grants to do research, and many more roles. And then for students are getting, students' interest, expectation is increasing. They want to learn something new and fresh. Of course, in the worldwide trend, we can see that electrical and computer engineering department students, every year intakes are getting lower. But again, what are these things that we can do to overcome? The other challenge as a professor, if you do work as a professor, funding is so difficult. Just to ask for money to do a project or to do a research is like you have to ask a lot of people. And this is true everywhere in the world, not only in Korea. Technologies. Technologies are moving so fast. Of course, you know that 5G is another two more years from now. And then let's say talk about what you teach today. You want your student, when they graduate, what they learn is relevant. You do not want your student, when they go out, something that is already out of trend and it doesn't help them in their career. So Keysight actually today, we are bringing our insights, how we can help educators to increase the interest of the student. While we look at becoming a solution like comprehensive, real world, up-to-date, and expandable. So comprehensive in the sense of we teach anything that what Keysight are looking at. Like you can see that when we design a product, we took in the knowledge and put into the courseware and teaching slides, and also the lab materials. It has to be real world. Reason is, we want to emphasize a lot about industry relevant, industry ready. So if you are a hiring manager or a project manager, when you hire a fresh graduate who just finished university, you can get him immediately on board to work. Otherwise, maybe you're going to spend another 3 to 6 months to train him or her. Up to date, Keysight is very committed to do content update for the materials that we are providing, the teaching solution and the material. Means that, let's say, assuming LoRa is something coming out, but when LoRa or Zigbee is gone, what is the next trend? Of course, you need to rewrite the content again. Well, Keysight actually, we are committed to do this content update for you. And finally, expandable. Now, the way how we look at this concept is not fixed. We want to give educators as much flexibility as possible. Things that we put in, you can customize, you can put in your local content. We also give the educators a flexibility to put in like how to address community problem, how to address a farm, how to do a smart farming project, and so on. Okay, if I move the slide overall. So next time when people ask what is IoT, you can actually say it is an end-to-end ecosystem which consists of device layer, connectivity layer, data center, and app layer. So today our teaching courseware actually covers fundamental. We teach a student, even you can use for teaching our parents if they ask what is IoT, we can say, oh, it's actually from sensors all the way to the data app layer from our mobile phone, how we use these apps, right? Then system design, IoT system design. It is nothing new. It's actually embedded controller, like what we learned in the university. What is different is we actually include the wireless technology and cloud computing. So with this new knowledge, students able to learn, able to relate, hey, I'm measuring data, and then how am I measuring this data? I'm using a Bluetooth low energy, capturing the signal to the board, send to the cloud and process it. And then from the cloud, download again to the board, push up to your laptop or your mobile phone. Then next one, we also put in a very interesting question to the student or the educators. With so many IoTs, wireless protocol going on, how can we ensure that there's no wireless interference? Maybe if somebody put out a signal, can jam your signal. But again, we want to show the student, hey, when you do all this kind of project or wireless, you're transmitting signal, you can actually visualize and see and measure. And finally, the IoT, the program we focus is sensors and power management. So if you have a IoT device, but again, if your IoT device is not designed to consume optimal power, you have to change the battery. Just imagine if I put a pacemaker in my heart to regulate the heartbeat, do I want to change the battery like every 2 years? And I have to see the doctor, make an appointment, cut, take out the battery and replace. It's crazy, right? So maybe I want to have a battery, the IoT device can last 10 years. Or maybe I start to see, because by being myself in the research area, I see a lot of scientists. They're also talking about wireless charging, how to do that. So it's very interesting. I think you will see this thing very soon in the future. Now, let's look at I will just briefly explain this. What we cover, IoT fundamentals. If you look at here, we have the teaching slides. It's in PowerPoint, it is editable. Training kits as well, lab sheets material with the model answers. Now, as an educator, we know that it's so challenging for you to do a teaching slide. What else if you're a lab manager or lab engineer, you have to write the lab procedure, make sure it's correct. Well, Keysight actually completes all of this. You can edit and customize it. We also put in the learning outcome. What do we want the student to learn? In this example is demonstrate the understanding of IoT architecture, technologies, standard wireless, protocol, application, and ecosystem. So it is end to end. Now we put actually make recommendation. What year a student will actually need to learn this. Of course, here we put second year or third year onwards. Fundamental prerequisite, a C programming is a must. Next, very similar to fundamental. What is different right now, you see the instrument setup here. Because this time, we want the student to learn to measure, to put an oscilloscope probe to measure the signal. I know there's already like, maybe you hear about Arduino, Raspberry Pi, or BeagleBone. These are all hobbyist kits. Yes, it's very good for IoT learning. But again, that is very suitable for computer science student learning. Because computer science student learning is, they just need to connect the sensors, do the output, and then how to manage the data. But again, as an engineer, we need our student to learn engineering, what is happening behind all this operation, the data. So here is about design and develop IoT embedded system, configure the IoT system. We have project and mini assignments for the student to do this on case study. So let's say build a smart home monitoring. So you use the sensors. In fact, this little red thing, we have a booth outside down floor, on the 5th floor. This sensor is from Texas Instruments. It's a 10-in-1 Bluetooth low energy sensors. So you can actually send data, send to the board and process it, measure using scope and our DMM to measure the wattage. And again, we set up a wireless LAN, Bluetooth low energy, Zigbee wireless connectivity. So the teaching material has all this wireless technology enabled. And finally, again, just like if you use again the hobbyist kit, you are not able to see the signal. But again, Keysight wants the student to learn how to evaluate a signal and perform current drain measurement. I think previously there's a speaker who talked about battery drain analysis. This is one of the lab that we provide as well. Now, most importantly, when it comes to wireless, everybody is firing data across. Again, what is different is the instrument, but the learning outcome will change again. In here, we want to demonstrate the understanding of major wireless technology for IoT. You got this mobile network wireless. You got a non-mobile wireless technology protocol like Wi-Fi signal. Then how do we choose? What is the correct protocol? Also, again, secondly, understand and measure impairment affecting radio performance. In this case, we want to measure interference. We teach the student to use spectrum analyzer to do interference analysis. What is the channel power? What is the adjacent power? So these are the things, probably my time, maybe let's say 20 years ago, I did not have such access to this instrument. But again, if you look today, technology is moving so fast. Can we afford to train our students, like 10 of them go for training and then wait? What about, let's change the concept of learning engineering. We start from university. Impart this knowledge early to them, use the tools, and they're ready to work. Finally, is evaluate wireless technology, all this technology here, using leading edge tools. Here, we actually recommend third year student to final year student. our module 4, focusing in IoT sensors and power management. Like what I said earlier on, maybe in Korea, you have a lot of agriculture and farming area. And then you want to measure the soil moisture, and then you put an IoT measurement, the farmer. So for the student project, you have to measure all this data, you have to collect it. And then we want to teach the student, how do I decide which sensor is good, which sensor is not good? And this is a program we teach. Understanding the sensor selection, understand design correction, evaluate performance. So we have a lot of material available in the web. We also have a free sample for you to use. Okay, I'll just quickly go this. Of course, I think this morning you hear Huisin mention that we actually, POSTECH has adopted this IoT teaching in their program, which is a great good news for Korea itself, for the student to apply this. Yep, and then again, we did a survey in US, in America as well. Last year, we have 21 students who took the class. At the end of the semester, we actually interviewed them. So how they feel about it. So you can see, this is my last slide actually. Out of these 8 questions, you can see that above 70%, or probably overall if combined, more than 90% students agree and strongly agree that this courseware, it really helps them. And I really pointed out that number 4 and number 5 is, I believe I'm a better engineer as a result of taking this course. See, it's above 50, almost 50, it's like, maybe like almost 90% students agree this. In fact, I can say that immediately after this course setup, the UNIC decided to invest even more and run this program for the student. That's it, thank you.